Mr. McGrath, and you have just hopefully received this box full of goodies for the bouncing bubble investigation. And so let's open it up and let's see what's inside. So the first thing we're going to find inside are going to be a booklet full of notes. So this is part of my STEAM Academy workshops. I have another one which is the giant bubble workshop, and then we've got the mysterious microbes. And hopefully by the time you open this up, there's going to be others. So keep an eye on my website to find out about all of the new virtual workshops that are coming on board. The next thing you're going to find inside the box are going to be the giant bubble kit, and there will be a bag which will have a whole load of little goodies inside. So let's have a find out what they are. So we've got a bubble blizzard, bubble blower blizzard. We have got some crazy soap, some foam. We have got a rocket balloon. And the last thing that's in there is a tube of bubbles. And all of these things are going to be used in the introduction video that you will be showing your children with me doing a little bit of my science magic, my little kind of crazy show. And so during that section, I'm going to ask for a volunteer. You're going to pause the video and the children can do the activity. And it's up to you. One child could do it, or every child could do the activity before you start again. It depends on the amount of time you have and obviously how many children you have there. And as we go through the show then, I'm going to be talking about forces and properties of materials while we're playing with all of these lovely bubbly gadgets. And then the next thing that we have in the kit is the equipment that we're going to need for the investigation. So we're going to assume that you've got 30 in your class. You may only have 20 and will have ordered 20. You may have 150 in your event and would have received a bigger box. So let's assume we've got 30. You will get 30 of these 5 milliliter pipettes. And you will also get 30 of these gloves. So a big amount of gloves. And these gloves here, they're stretchy and they're woolen, and this is the key part of the workshop. You will also receive 90 of these 30 milliliter measuring cups, and you've got 2 bottles of glycerine. I know, and this box still keeps giving. And then we're going to have some stirrers, and then we have got big pots. So these are 300 milliliter pots with a lid. And the last thing inside the box is Activora. Now, this kit has been devised as a make and take activity. So I'm expecting the children to make their bubble solution, which will create a bubble which we can bounce, and then they can take it home in this container. However, you may decide that you're going to want this as a school activity, and it's going from classroom to classroom to classroom. And this is where the Activora becomes important. There are a whole range of chemicals which are good at killing microbes, viruses and bacteria. And so we have alcohols. We don't want those in school. They're flammable and they're poisonous. We have others like bleach and hydrogen peroxide, which are oxidizers. Again, they're nasty for the skin. Another group are reducers. They're acidic. Again, nasty for the skin. Or you've got these ones here. These are ones that are called quaternary ammonium salts. Guess what? I've told you all about them in here, right? Now, what you're going to do is you're going to spray the children's hands with this. It lasts for 24 hours. Not only does it have the bug-killing properties, but the liquid that they're mixed in is like a very thin slime. So it sticks to the surface, or it sticks to your hands, keeping all of those wonderful chemicals, which are biocides, that are going to kill the viruses and bacteria there. And that means then you can spray your gloves, and your class can use the gloves, and then they can move on to the next class. And at the end of the day, we can wash them plus 60 degrees, and then they can be used again on the next day. So this is a very cost-effective workshop if you want to take it down that route. So basically, that's what we have in the kit. What do you have to supply? So the first thing you're going to have is fairy liquid. And it has to be, unfortunately, the original or the platinum. I've tried every single washing up liquid that is out there, and by far these are the best. You are going to need water, and you can supply the water in small jugs or as water bottles for them to use. And then the last thing you're going to need is a pair of scissors. So I'm going to go through the workshop now and explain to you how to set it up so that you have as much done before the children arrive in, and then hopefully see some of the wonderful magic that it will produce. Throughout the show, I'm going to be using a whole range of toys and gadgets. Some of them you'll just find in Tesco, such as this one here. Others you're going to be able to find on my shop, sciencelife.com. Some of them you might find in B&M, The Range. Lots and lots of shops have lots of different bubble gadgets. And some of the things are going to be homemade. And so what we want to be able to look at, first of all, then, is as we go through the show with the bubbles, if we have a small bubble wand, then we're going to make small bubbles. Oops, baby bubble at all there, did it? So a small bubble wand, I'm going to get small bubbles. Do you notice the way, though, as soon as I make them, they fall down to earth? So whenever we're looking at bubbles, it's a great way for us to bring in the language of properties of materials and forces. This one I just love. We're not going to use our lungs to make these bubbles. It's going to do it for us. There's a fan there that's going to push its way through a small bubble wand. So we're going to get small bubbles, and we're going to get a whole range of bubbles. And then it's just going to start to snow or rain bubbles all around me. They love this. They can watch them. They're not going to be able to catch any of the bubbles because as soon as the bubbles touch a dry surface or hand, a dirty surface, then they burst. So one of the things that we're going to be looking at is making, as I said, the bouncy bubble solution. And there is a toy that you can buy in the shops that has the wands and has this as a blower. And this one here lets us, oops, hopefully, we'll get fairly good sized bubbles. The other one that I've got, though, is this bubble blizzard. And it has got many, many small holes. So it's going to allow us to make a foam. Now, because of those holes are so small, they're not as small as they are with the sock I'm about to show you, but because of the size of the holes, we can still see the bubbles that are there. But as the holes get smaller, and as the bubbles get smaller, then the foam has really weird properties. For this one here, the next one, you're going to have to get a bottle and cut the bottom off. These bottles here, so water bottle, they're really easy to cut. Some of the others are not so easy, so take care. And then you need to get a sock. So we put the sock over the end. You can get the children to look through the sock, and it doesn't have to be a sock. It could be a circle or a square of cloth, and you can use an elastic band to keep it in place. But these holes are tiny, tiny, tiny. So when we put it into the soap solution, we're going to get really small bubbles. It's much more foamy. Now, again, when you do this, don't have a big pot of bubble mixture because they'll dip the whole sock into there. So you just want to have a small tray and put a small amount of bubble solution on there, making sure that they're not getting too much of the bubble liquid on the sock. And another reason for this is the fact that you have to make sure that when the children are going blowing and not sucking, because if they start to suck in, then they're going to get soap in their mouth. So have a little drink of water or juice handy just in case that happens. So that's that one there. So that's looking at foam. And another one that I've got, I'm going to dry my hands here. Another one that I've got are these bath foams, and they come in a range of different colors. So I've got purple, white, blue, pink in the shop. You give them a shake. We're going to experiment with the fact that the gas in here is flammable. So we'll look at that in the show. But because of the bubbles are so small, this is actually bouncy. And they can use different forces to change its shape. They can pull it apart. They can make a snowman. In fact, they can make any kind of crazy design that they want, and then they can squash it and change its shape. Lovely. And you can mix them and get lots of different colors as well. Again, in the show, I'll be talking about color changes using this bubble bath. Now, you can get it in the range, but you can also get this on my shop. So inside here is a chemical called bromocresol green, which means when it's neutral, it is going to give us a green color. We've also got some citric acid in here, and the citric acid makes it an orangey color. And then we're also going to be using baking soda, which will make it blue. And we'll mix the two together and we'll form carbon dioxide gas, and we'll get a lovely overflowing bath bomb taking place. Now, obviously, being virtual, I'm limited to the space that I can be working at here. But in the classroom, if you want to repeat some of these experiments, you can space everything out. This box here is a nice lid, stops the liquids going over the edges. I've got a plastic covering on the table. That's perfect for them making the foams. And I've done the foam with many, many groups, and they just love for 10 minutes, 15 minutes, just blowing and creating these foam structures all over the table. Because the bubbles go up and down, safety glasses might be required. So I'm selling these ones here. But any goggles, swimming goggles, sunglasses, anything that's going to stop a bubble going into their eye and bursting. And if it does, it's useful to have an eye rinse handy, or a bottle of water. So if you tip them sideways, you can rinse the soap out. The soaps are not going to do any damage, but we all know what it's like with shampoo in our eyes. It's a little bit sore, and some of the children are going to react emotionally more creatively than others. And then the last little toy that I'm going to be using is a giant bubble wand. It's not really gigantic, but it's much bigger than what we've been using. And again, it's a lovely way for us to explore the fact that water is stretchy. Stretchy due to the fact that the water molecule, one side is positive, the other is negative. So if you rub a balloon on your hair, you're going to get your hair moving up and down as you move your balloon closer and further apart. That's exactly what happens here. And if I stretch it too far, then it will burst. We don't get a bubble, though, until we actually close that loop. And again, these are in the shops. I haven't seen them locally, but I'm sure you'll find something similar. You just need to make a hoop and get your soap. But if you're very careful, you can blow little bubbles inside. And then, just with a balloon, when you blow a balloon up, it stretches. If you open the end, the air will go out. And that exactly same thing happens with a soap film. Hello, Amy. Thank you so much for coming in and helping us explain what this bubble workshop is all about. And one of the toys that's in it is this thing called a giant bubble kit. And the second thing that we're going to have in the bag are bubbles. So we've got a little set of bubbles here, and inside the bubbles there is a little pesky bubble wand. It's a little bit slippery here. I know, we're trying to get that out. There we go. So we're going to have that out there. We've also got something called a bubble blizzard. And if you see, there's lots and lots of little tiny holes in there, and we're going to get you to play with that. And the last things that we have will be foam. So what I've got here is I've got pink and blue foam, and we're going to play with those. And the very last thing that's in there is a rocket balloon. Okay. Okay, and so when we start the video, the children are going to be watching, and I'm going to do some crazy little things, but I want the children to be able to be interactive as well. And so there's going to be times when I'm going to say, I need a volunteer, and you as the teacher then will switch the video off, and you're going to choose one of the children. And this could have been pre-chosen, so you don't have to. You may have said right at the beginning, I'm going to need 5 volunteers, and if they've had brilliant behaviour for the week, they're going to be the 5 volunteers. But what's also lovely about the way that this workshop is going is if you've got a lot of time, then every child in the room can have a go at the activity before you start again. Yeah. And when I started the workshop, I had a big bubble blower. So I've got another one here. So again, as teachers, you can have a whole range of bubble toys that you can be using, which are going to get the children to look at it. Now, if we watch this bubble here, it's going to fall down due to gravity, but using the air, I can then move it from me and to you, and back to me, and so because it's wobbling, we can then use the whole idea about talking about forces, right? Yeah. Now, so what I'd like you to do now is with the bubble maker, we're going to get the children, first of all, to move it up and down gently and then to stop. So I'm going to get you to do that for me, please. And while they're doing this, we can start talking about trampolines, because a lot of the children these days are bouncing up and down on trampolines, and that surface is elastic, and that's exactly what the surface of bubbles are. They're very, very elastic, and if you put it sideways like this and wobble it like that, again we can see it's going to stretch, and we stop the forces and it goes back to its normal shape. It's not formed a bubble. So we need to be able to trap air into this. So what I tend to do is I'll have my hand out there and I'll get the children with the wand to follow the direction of my hand. Go through that again, go in a circle, and we catch the bubble. And again, we can use forces. Okay. And this time what I want you to do is I want you to make a bubble, but you're going to turn the wand upside down and you're going to catch it on that side. Yeah. Okay. So let's see if we can do that. Oh, that's it. Brilliant. Well done. So I'm going to be in the video showing how these bubbles are made. And this is something that you as a teacher could practice before the children are there. Actually, well done. Look at this. We're playing a bit of bubble tennis. There's lots of little things that you can do here that are going to make the children be well. So normally in a show, it's me. You now have the opportunity to skill up to play. Exactly. And for some strange reason, every household seems to have a bag full of odd socks, and that's what we're going to be using here. And what you can do then is have just a little tray with a small amount of bubble liquid. So you might want to stand up for this one, Amy. And don't have it too deep, because of the whole sock will end up going in. And what I want you to do is just dip it in so the end gets wet. Perfect. And then you're going to blow it down over the tray. So if this is outside, then can you see how much smaller those bubbles are? And they're wiggly. And so what we've got there is we started with bigger bubbles. They've got smaller and smaller. What happens if the bubbles are really small? So I'm going to keep you standing up, Amy. And what we're going to do is we're going to look at this foam. So when you get these, you're going to give them a shake. So I'm going to let you shake that one there for me. But what I also wanted to point out is it's not filled with air. It's filled with a gas called butane. So you can't have any candles near this, because as the bubbles burst, we're going to end up releasing this butane. But who has this been made for? Kids. Kids. For the bath. And unfortunately, there have been some sad accidents where somebody has had a bath filled with all these bubbles. I don't know whether it was a cigarette or a candle or whatever, but there's been disasters in the bath. So this is a very good time to start talking about danger symbols. So when we press the button, so we're going to put a small amount on our hand, it makes this wonderful mix. So you can put your can down, no, that's fine. But look, we can hold it. And then we can use very small forces and we can change its shape. So let's make it into a ball shape. And then we can bounce it.
You do this one.
In the show, you're going to see me bring this balloon out. I filled this balloon with some helium gas. So this tube fits onto the end there, and then I can put the gas in. And then what I've done is I've used a clip here which holds the gas inside the balloon, and there's a cable tied there that holds the balloon onto the tube. And you can put air into it. I've put helium in. You could maybe put carbon dioxide gas into it and experiment with different gases. But today I'm just going to be using my little happy balloon with helium. So this is the booklet that you're going to find in your kit. And in the investigation, we're basically just going to investigate what is the best washing up liquid to water ratio to give us, first of all, the longest lasting bubble before we add in some glycerine, which will then allow us then to get it to bounce for a long time. I've given some of the science that I'm going to talk about in the show. I'm going to talk a little bit about bubbles and why they're coloured and why they're round, link to the curriculum, and mainly look at the fact that this is going to look at the fair testing aspect of being a scientist. And rather than me just talk about what we're going to do, I'm going to bring Amy back in, and what we're going to do is go through how we can set up the workshop, what will actually happen in the workshop, and then if there's any questions, then hopefully Amy will think of them and shout them out. But if you have any, guess what? Yes, you can phone me. So I'll give you an opportunity to give me a call or send an email and talk about some of the problems you have before you carry out the activity. Because I want this activity to be amazing for you and the children. So let's get Amy back in the room. Okay, so Amy, we've opened up the box, and I'm going to assume that we've got 30 children. And so it's much easier if we have the equipment either lined up in the class on the sides of the classroom, and then you've got a helper that's going to go and collect. So you're going to say, Mary, your job is to collect these. Joshua, your job is to collect these. Or if it's an event, then the easiest way is to have everything on a tray, or you can have a piece of kitchen towel already on the table with the items sat down on there. Okay, now having the kitchen towel already available is going to be useful because there will be spillages, okay. Right? And so first of all, the children are going to either take this home with them, or it's going to be rinsed out and used for the next class. It all depends on how you want to play with it. Mm-hmm. So if they're taking it home, then we can put sticky labels. With the investigation, not all of the children are going to be able to make a solution to begin with that's going to be bouncy, because that's the investigation. So once we've figured out the ratios, okay, those that don't have those ratios, their solution can go into a bucket which the staff room could use for washing up. We can reuse it, and then we can be labelled. They've got a stirring stick for them to stir. There's going to be the pipette, and again, it all depends on whether you're happy enough with your children using the scissors or not. So all I'm going to get you to do there is just to remove the top end of the pipette from there. So that's going to make our bubble wand. There, yeah. Anyway, yep, that's perfect. And then what we've got then is we've got 3 measuring cups per child. Okay. So first of all then, one of the measuring cups can be used already pre-measured. So what I've got here is I've got my glycerine pre-measured. Every child is going to use 5 milliliters. So this speeds things up. We're not investigating the glycerin. So I would actually have that pre-measured before the event. But if you've got an older set of children, then what you can then later do is investigate the amount of glycerine that's added to see if it has that happens. Okay. The next thing that you could have pre-measured out is the washing up liquid. So they're all going to be using 15 milliliters of washing up liquid. Again, that could be pre-measured, or if you've got lots of time, then you can allow them to come up to the station and do it themselves. If I'm doing this at a festival, I will have these pre-measured on the side, and then as I'm talking, I'll go around and hand it to them. The one thing that they are to measure, though, is the amount of water. That's what they're going to be taking the times for. And so within the booklet, I'm going to be talking a whole thing about what a fair test. So we want to be able to make a bouncing solution, but what we need to do is we think, what are we going to be using? So we're going to be using water, we're going to be using washing up liquid, we're going to be using glycerine. And there's lots of things that can vary in that. So we've got lots of different types of washing up liquid. So I'm letting you know the best one. Trouble is it's the most expensive, but that is the best one. So that's one investigation. So that's now under control. It's already done. But the next thing is the weird thing is the water, and water can arrive from the taps, can arrive in water bottles. It can be river water, it can be sea water. You know, whenever you just say people to use water, there's lots of different things. Now, we understand that seawater is salty. It's got salt dissolved in it. But a lot of rivers that come through our mountains, they will also pick up different salts. And that means that our tap water is also got these salts in. And it's very difficult to get bubbles in that type of water. And so we say that water is hard water. And the children may live in homes where the pipes clog up, fur up, the kettles fur up. In Belfast, we don't have that problem. We've got nice soft water. So again, if you're in an area where the water's hard, then you're going to have to get bottled water or go to Halfords or Tesco's or places where they get big bottles of what's called deionized water. Okay? And they normally come in bottles like this, 5 litres of water. And so what we're going to do then is you can have small jugs on the table or larger jugs on the table, and so they're going to be there for the children to use in the experiment. Now, I started the show talking about toys. It's always good to have toys, and you don't necessarily have to let the children use the toys. You can just say, it's my toy, okay? But it's really good for them to be able to think about the bubbles, and what they're going to be doing is making bubbles. But each of these bubbles are bursting. So first of all, what I want us to do is we're going to make a bubble. So that's yours there. And this is the pre-bought bubble solution. And I'd like you to put the glove on either hand, whichever hand you want to put it on. That's it. So with the other hand, this is the pre-bought bubble solution. You're going to dip your pipette in, and you're going to blow down through this. So at this stage, if the children are sitting down, it's going to be quite awkward. So we're going to need to get the children to stand up. And what size of bubble are they going to make? So we all have to make the same size bubble. So I tend to have a tennis ball handy or an apple handy or something, and then they're all going to try to blow a bubble that size. Okay, and put your finger at the top. Already it's burst, you see. So what we're going to do is we're going to count how long it takes for the bubbles to last for. And so for us to be able to remember this, we're going to need a results table. So again, in the booklet, I've given you guidance of what the results table could look like. Okay? And what we've got here then is a results table for us to write down. And so with the shop-built one, it didn't last very long, right? But maybe the shop-bought bubble solution will be bouncy. So what I want you to do then is you're going to make a bubble. You hold it away from you and you give it a little flick and let it drop, and then you can catch it. Okay?
Yeah.
And all we're doing to begin with is letting it land on the glove. Always trying to make sure we're blowing a bubble that's the same size each time. And it burst. That was rubbish. Yes, it was. So obviously this is not the solution that they sell in the kit. So we're going to remove this out of the way, and what we're now going to do is we're going to see if we can make our bubble solution. So you've got your pot there. We're going to sit down, and you can take your glove off now, and you're going to have your washing up liquid, and we've got our first amount of 15 milliliters. And so I'm going to let you do the first one because we're working in pairs. And you do the first one, and I'm going to put the results in, and then I'll do the second one and we'll put the results in. Now, if you don't have a lot of time, what you can do is you can split the group up into sections. So what we're going to do is we're going to do this 8 times. And so the first bubble solution is going to have exactly the same amount of water as there is washing up liquid. So we're going to have 15 ml. Then we're going to double it up. So we're going to have 15 milliliters, 30 milliliters, 45 milliliters, etc., etc. And we don't do this just once, because as you saw, just even the two of us using the same solution, they've got different times. Now normally in a lab we would maybe repeat it 10 times or 50 times. We're just going to repeat it 3 times. But this allows us then to bring in some mathematics, because we're going to get the children to be adding those numbers up and then dividing by 3 to get an average. Okay? So you're going to mix them together into your pot. So 15 milliliters of your washing up liquid goes in.
Does it matter that it's
Doesn't matter. You can rinse it out if you wish with the water that's going to go in, or you can just put that down. I would imagine the children just want to throw it all in. Perfect. Great stuff. And you're going to stir it. So what we're both going to do then, we can, all we're doing at the moment, Amy pointed at the glove there. All we're trying to do at the moment is to find the solution that gives me the bubble that lasts the longest. Okay? So we're going to dip them in, and we're going to blow down. Get a bubble about the size of a tennis ball, and let's count together. 1, 2, 3. 23, it's about 24, 25, 26, 27, 40.
Mine's better.
41 it is. 42, 43, 43. Okay, now.
Okay, so it needs to be the same size.
Yes, so I was about to say that what we had there, Amy's bubble was a little bit smaller than mine. Maybe that would have been a problem. So what we're going to try to do is make sure they're always the same size. So let's do that one more time. So we've got 24 seconds, we've got 43 seconds. You do it one more time, and then that will give us a third reading. Okay? Perfect size. Now, Amy's counting in her head so that I can talk to you. Let the children notice that as the bubble is sitting there, they're going to start to see lots of colours, and you're going to see movement on the surface, because gravity is pulling the liquid down. And evidence for that is every now and again we get a little drip going there. 22 seconds. Brilliant. So what we've got there is we've got 20, 24, 43, 22. And we're going to get an average. Now we're going to add in another 15 milliliters of water. So we've got the 15 milliliters. They might want to use a little black pen to notice that off. So we're going to give that a stir. That's stirred in. Okay. Now, if we're working in pairs, we might decide that we're only going to do 2 readings and take the average, or 4 readings and take the average, so we're both doing this at the same time. Okay, so let's dip in. Let's form our bubbles together. Now, I know, looking at this, my bubble is about to burst very soon because it's starting to lose the colour and go very black at the top. So give it a little flick. 1, 2, 3, 4, 5. Oh, 5. Now, let's do that. So, the reason we've gone through this is to realise that sometimes they burst immediately for whatever reason, which is why taking readings 4, 5, 6 times is best, because we take an average. What you'll find is having a ratio of 1 to 5, 1 to 6, 1 to 7 is the best, depending on the temperature. If it's very hot, you're going to want more water.
Okay.
Now, so we do know it bounces, but it's not bouncing a huge amount. So within the class, you are all going to agree which is the best ratio, which bubbles last the longest. And once you've got that, you're then going to put in your glycerine. So can I get you to pour that in, and you're going to give it a stir. Remember, the water molecules are charged. And so what's happening then is by putting the soap inside, we're making them move apart, and we're allowing them to act more like a spring. The forces between them are weakening, so they don't burst immediately. But again, with the temperature, the water will start to evaporate. So what we're putting in here is we're putting in a sugar. So this is where we can do another investigation. So once we've found out the best solution, we can then look at the best sugar. Is it going to be granulated sugar, honey? Is it going to be cornstarch and things like that? So let's try this again.
So am I doing a bounce?
So you're going to do a bounce. So sometimes it might be best to get the whole of your syringe wet before you make a bubble. And then the next thing is looking at the force at which you push it. If you push it with too big a force, then that changes the controls.
15. Yeah, it's
So
a bit softer.
Yeah, so in the class now you're going to have a competition to see who can make a bubble. Now, how much water did we have in there? We remember because we wrote it down. So we're going to make the mixture again, and this time we're going to stick with our ratio of 1 to 6. And so can I get you to pour that into the bucket beside you? So if this is going to be an activity where you just want the children to make the solution, then they can just add in their 15 millilitres of washing up liquid. If you run out of glycerin, then you can just go into the food markets and you can get smaller bottles of glycerin. And we're going to measure in this time. I'm going to put in 10 millilitres. Okay, so we're going to go back to that first measurement. So we're going to go to 75 ml of water. And there we go.
75.
75. So I've got 15, 30, 45, 60, 75, and we're going to put in 10 millilitres of our glycerine, and let's see how that works.
Obviously, I'm stirring it and getting bubbles.
That's right. But what's lovely about this is because we can buy this in supermarkets and they get the washing up liquid, and the majority of them will have gloves, that if it's not a make and take, they can go home with the recipe and they can make this at home. And the only thing they're going to need to go with is going to be the pipette. So what we have here now is 15 milliliters of washing up liquid, Fairy. We have 90 milliliters of water, and we have 10 milliliters of glycerine. Oh, we've got some skills going on there. It is a wonderful activity to train the children to have small, gentle movements. And while they are holding their bubble, you can look at all the fantastic colours that are in there. Okay.
Ooh, 19.
Oh,
20.
So we've got the 20.
21.
Oh,
22. 23.
and pass to me. Ooh.
Oh.
Now, would adding more glycerin make it stronger, weaker? Should we use a different sugar? We've got all these things that we can get to experiment. That's the experiment that you're going to do in the class or at your event. They can now go away, remember, and they can repeat this back at home. They will have their pipette, they will have their glove, and all they need to do is to get the glycerine or honey or any of the sugars and the washing up liquid. So enjoy the workshop. Enjoy the little show that the children are going to see, and remember, if you have any questions, please email me. So we've got scientificsue@sciencetolife.com, and I will answer any questions. And Amy, thank you so much for coming in.
You're welcome.
To help me go through that. So enjoy. Bye bye, everybody.